With the casing already off, he's ready to continue disassembling the pump. The first step is to loosen the packing gland nuts. This is done to release the pressure on the packing and shaft, allowing it to rotate easily. First, he loosens the nuts with the wrench. When they're loose enough, he threads them almost to the end of the studs by hand. These pumps are supplied with glands that have either 2 or 4 studs. In this case, 4 studs are used. Next, the workman removes the impeller. To do this, he places an impeller wrench on the shaft. The shaft is rotated until the wrench strikes the workbench sharply. What happened was this. The impeller rotated with the shaft. But when the wrench stopped the shaft from rotating, the impeller tried to keep going a little. This caused the impeller to break loose from the shaft. It may take you several strikes of the wrench to break the impeller loose. Once the impeller is loose, it can be turned and removed by hand. With the impeller off the shaft, the workman puts it aside. He'll inspect it later on. The next piece to be removed is the end plate. The end plate is held in place by 2 cap screws, one on each side. The workman loosens them with a wrench. He places the screws in a plastic bag as they're removed. This protects them and keeps them from getting lost. If the plate can be installed in more than one way, be sure you match mark it to ensure it is reassembled properly. With the cap screws out, the end plate is removed from the pump assembly. He takes care not to damage the shaft as he slides off the end plate. Any nicks or gouges could prevent the packing from forming a tight seal. The only piece now holding the shaft in place is the bearing end cap. The workman takes it off by removing the 4 cap screws which hold it in place. As before, the cap screws are loosened with a wrench. Then they're threaded off the rest of the way by hand. Again, he places the cap screws in a plastic bag for safekeeping. Once the cap screws are removed, the cover is taken off. The gaskets are also removed. The next step is to remove the deflector. The deflector is made of Teflon and should slide off easily. The workman takes care not to damage it as he removes it so it can be reused. This part is also bagged. When we left the workman, he was ready to remove the shaft and bearings. Before we rejoin him, let's take a look at how these parts fit together. The shaft is supported by 2 bearings. The bearings are press fit onto the shaft. A slinger ring is also pressed onto the shaft. Its purpose is to sling the oil as it rotates, forming an oil mist inside the bearing housing. This lubricates the bearings. The bearings are held on the shaft by a lock nut and washer. The lock nut is threaded onto the shaft and held in position by the washer. The first step is to bend up the lock tab on the washer so it clears the lock nut. To do this, the workman uses a punch and hammer. Several taps with the hammer may be required. Be careful not to damage the lock nut when you do this. Once the tab is clear of the lock nut, the workman places the impeller wrench on the shaft. He aligns the key on the wrench with the key slot of the shaft and slides the wrench on. This will hold the shaft steady while he uses a spanner wrench to loosen the lock nut. Notice that he holds the spanner wrench tightly on the nut to prevent it from slipping and rounding off the slots. When the lock nut is loose, he no longer needs the impeller wrench. The lock nut can now be rotated by hand. Don't spin the nut off. These are fine threads and may gall easily. After the lock nut is removed, the lock washer is free to come off. He places both the nut and washer in a plastic bag. The next step is to remove the snap ring. To do this, the workman bumps the shaft out a little ways. This gives him room enough to insert the snap ring pliers into the snap ring. Notice that the workman holds the ring in his free hand as it's removed. This keeps it from popping off. With the snap ring off, the workman removes the shims and stores them with the snap ring. These shims are used to set impeller clearance. The shaft is now free to be removed from the bearing housing. Take extreme care when removing the shaft and bearings. They fit in there snugly. As the bearings come free of their seat, there may be a tendency for the shaft to drop. Be sure you don't let this happen. If the shaft hit the housing, it could be damaged enough so that it would have to be refinished before it could be used again. The workman places the shaft on a set of roller V-blocks to keep the bearings off the workbench. He then covers the bearings to keep dirt from getting into them. Dirt in the bearings will damage them when they rotate. The coverings are taped on. This prevents them from being blown off or accidentally knocked off. With the bearings covered, the workman is ready to make out identification tags. These tags will identify the parts contained in each bag and will help the workman during reassembly. This is an especially good practice if a different workman were required to reassemble the pump. This may take a little time, but it's worth it. It will save you time in the long run. The more complicated a pump or job is, the more difficult it becomes to identify the parts. With the parts tagged, you'll know exactly what they are when you get ready to put them back together. With the tagging completed, the workman removes the gland nuts from the gland studs. Then the packing gland follower is removed. All the parts are bagged for safekeeping. Next, he's ready to remove the packing and seal cage. Since this is a new pump and the packing hasn't been compressed, the workman is able to pull it out by hand. If the packing were old and compressed, the end plate could be turned over and the packing pushed out. So far, we've watched the workman disassemble the pump. Now he's ready to remove the bearings. This pump has two bearings. The inboard bearing supports the pump shaft. The outboard bearing has two functions. It also supports the pump shaft, but in addition to that, it minimizes end play or the sideways movement of the shaft. This pump is designed so there is a minimum of end play. For this reason, a double row bearing is used. Both bearings are press fit. That is, they must be installed and removed using a press. The workman has completed removing and inspecting the bearings. Now he's ready to inspect the rest of the pump parts. With the bearings off the shaft, it can be inspected. Before starting the inspection, he uses a soft cloth to wipe the area where the bearings seat. This is to ensure there is nothing on the shaft which will interfere with the measurements that are to be taken. He'll be checking for deformed bearing seats. To do this, he checks the manufacturer's instructions. They give him the specifications of the seat area. Using a micrometer, he measures the first seat area. He takes 4 readings, a pair of readings 90 degrees apart at each of 2 locations. These readings are recorded so they can be compared to the manufacturer's specifications. In addition, the readings taken at 90 degrees to each other are compared. If there is a significant difference between them, the seating area is egg-shaped. Another comparison is made between the readings taken at each of the 2 measurement locations on the seating area. Any deviation between these 2 would indicate the shaft is tapered between the 2 measurement points. The 4 measurements are then repeated on the area where the second bearing fits. If any of these readings are out of specification, the shaft would have to be repaired or replaced before the pump could be reassembled. In this case, the workman found that the readings were within the manufacturer's specifications and that the seat areas were not egg-shaped or tapered. Let's rejoin the workman as he checks to see if the shaft is straight. With the seat measurements complete and the blocks repositioned, he's ready to perform the shaft runout. This will be done using a dial indicator. In this case, he's using a dial indicator with a magnetic base, which will hold it firmly in place. With the indicator tip resting lightly on the shaft, the workman aligns the indicator needle with 0. Then he rotates the shaft 1 full turn. Watching the dial, he notes any deflection of the indicator needle and records the amount so it can be compared to the manufacturer's specifications. Then the indicator is moved to a second location where another reading is taken. As before, he aligns the needle with 0 before rotating the shaft. Each reading is recorded as it's taken. These same measurements are then taken at the other end of the shaft. The dark center portion of the shaft is not a machined surface, so the dial indicator is not used there. The final measurement is taken on the very end of the shaft. Additional care must be used when taking this reading. The keyway for a coupling is cut into the shaft there. So the workman takes his reading from one side of the keyway around the shaft to the opposite side of the keyway. The tip of the indicator should not be allowed to go into the keyway. The indicator is fragile, and this could cause it to be damaged. The workman found the shaft runout to be well within the manufacturer's specifications. With the shaft inspected, he's ready to inspect the impeller. The first thing he'll do is remove the impeller gasket. Whenever you disassemble a pump like this, replace the gasket. The gasket protects the threads of the impeller shaft from becoming corroded. It should be in good condition. The workman then inspects the back of the impeller, paying special attention to the equalizing holes. These holes help equalize the end play on the shaft. Next, he looks down into the vanes of the impeller. He's checking to be sure they are free from any obstruction. The ends of the vanes are also checked. What he's looking for here is wear. Next, the suction eye of the impeller is checked for wear and corrosion. Then the impeller is wiped clean. The impeller gasket groove is checked and wiped to ensure there is no dirt present. Dirt would prevent the gasket from seating and forming a good seal. With the seal groove clean, the workman replaces the impeller gasket with a new one. The new gasket should be slightly above the edge of the impeller face. This is to allow the gasket to compress, thereby sealing the shaft thread from the fluid being pumped. The workman has completed disassembling, cleaning, and inspecting the pump. If any of the measurements had been out of specification, the necessary repairs would have been made. In this case, all measurements met the manufacturer's specifications, so the workman is ready to begin pump reassembly. The first step is to press the bearings back onto the shaft. Next, he places the lock washer on the shaft. He makes sure the tab fits properly in the keyway. This prevents the washer from turning. Then he threads the lock nut onto the shaft. He continues threading until it is hand tight. With that done, he places the impeller wrench on the shaft. This is to hold the shaft steady as the lock nut is tightened. The workman uses a spanner wrench to tighten the lock nut securely, holding the wrench tightly to prevent slippage and possible damage. With the lock nut tightened, the workman removes the impeller wrench. He then turns the shaft to find the tab on the lock washer, which is lined up properly with a key slot on the lock nut. Using a pin punch and hammer, he drives the tab over the nut, locking it into position. Next, a cone is threaded into the end of the shaft. This allows the seals to slide over the shaft easily, preventing them from being damaged. The shaft and bearings are now ready to be installed into the bearing housing. They must be eased into the housing. The bearings fit snugly, so be careful not to cock the shaft. That could jam the bearings, possibly causing damage. Care must be taken as the cone slides through the inboard oil seal. The oil seal has a press fit and is replaced each time the pump is disassembled. With the shaft in place, the workman installs the snap ring. He slides the ring over the shaft. Then he uses pliers to open the ring to allow it to slide over the bearing and into its slot. The shaft is then pushed forward as far as possible. This seats the snap ring against the bearing housing. Next, the deflector ring is installed. The workman slides it over the shaft and up against the inboard oil seal. If it's not positioned properly, it won't keep other fluids away from the oil seals. As a result, these fluids could enter the bearing housing and cause bearing damage. With the deflector in place, the workman places the gland follower on the shaft. Be sure it is put on so the gland throat faces away from the bearings, toward you. Next, he installs the end plate. The end plate must be put on with the gland seal hole at the top and the cap screw bolt holes properly lined up. This is to allow the cap screws to be installed and threaded into the end plate. If it is possible to install the end plate on a pump you're working on in more than one way, match mark it before you remove it. That way you can make sure it goes back on the same way it came off. There's no gasket between the end plate and the bearing housing adapter. This is because these mating surfaces don't form a sealing surface. When the cap screws are hand tight, the workman uses a wrench and alternately tightens them evenly. Next, he removes the cone on the end of the shaft. This allows the impeller to be installed. Take care when threading the impeller onto the shaft. As with most threaded fasteners, spinning it on may cause thread damage such as galling. If this occurs, the threads on both pieces would have to be repaired. You may have to hold the shaft to prevent it from turning. Once the impeller is hand tight, the workman slides the impeller wrench onto the shaft. Then he rotates the shaft with the wrench. As before, the wrench stops the shaft while the impeller tries to continue rotating. In this case, the impeller tightens as it rotates. The impeller will tighten itself further when the pump is run. With the impeller installed, the next step is to set the impeller clearance. But before the workman gets to that, I'd like you to stop the tape and review your text. The workman is now ready to set the running clearance of the impeller. This clearance is very important because it affects the pumping characteristics of the pump. If there is insufficient clearance, the pump will pump below capacity or it may not pump at all. Let's join the workman and watch as he sets the running clearance of the impeller. Remember, the shaft has been pushed all the way into the bearing housing. The workman uses a feeler gauge to measure the clearance or distance between the impeller and the end plate. The feeler gauge should fit snugly, but not have to be forced into the space. You may have to try several combinations of blades. When the clearance has been determined with the feeler gauge, the workman then uses a micrometer to check the total thickness of the feeler gauge blades. Even though the feeler gauge blades have thickness measurements on them, you might have more blades than you realize. So by using a micrometer, you can be sure that your measurement is right. The clearance, which in this case is 92 thousandths, is recorded. Next, the workman checks the manufacturer's instruction manual. In the manual, he finds out that the clearance required for the service this pump will perform is 21 thousandths. This means that right now he's got too much clearance. He can reduce this clearance by adding shims. To find out how much shim thickness to add, he subtracted the two figures. This gave him the additional shim thickness required, 71 thousandths. Shims are supplied by the manufacturer in various thicknesses. The workman measures each shim thickness. Then he selects the combination that will add up to his desired thickness. As he selects the shims, he sets them aside. To double-check this combination, he then measures them together. Next, he removes the snap ring to allow the shims to be put on the shaft over the bearing. With the shims in place, the snap ring is then reinstalled to hold them in place. As before, snap ring pliers are used to spread the snap ring open, allowing it to be installed. The running clearance of the impeller is then rechecked. This is to ensure that the shims installed provide the desired clearance. The clearance should now be 21 thousandths. Since he knows the desired clearance, he selects the blades that fit into the clearance gap. As before, the workman double-checks the thickness of the feeler gauge for accuracy with a micrometer. With the running clearance of the impeller set, the workman is now ready to put on the bearing cover. The thickness of the cover gasket is determined by measuring the thickness of the shims and snap ring. Then an additional 50% is added. This is to allow for compression of the gasket material. To select the proper gasket, the workman must measure the gasket thickness. Several thicknesses are supplied, and it may be necessary to put in more than one gasket. When the workman has selected the necessary gasket, he places it into the bearing cover. He also removes the cap screws from the plastic bag so they're ready when he needs them. Then the bearing cover is placed back on the pump. When you do this, take care not to damage the oil seal that's in the bearing cover. He seats the cover squarely on the housing. With the cover in place, the cap screws are put in and evenly tightened. Before the pump is installed, it has to be packed. The seal cage is also installed during the packing process. Finally, the gland follower is installed. The pump is now ready for installation. However, there is one important note of caution. Check the rotation of the motor that is going to be used to drive the pump. Make sure it rotates in the direction indicated on the bearing cover. If you install the pump with the motor rotation in the wrong direction, the impeller would be threaded off the shaft, possibly damaging the pump. Right now, I think we're at a good point to stop the tape so you can review what we've covered so far with your instructor. In the previous segment, when the pump was reassembled, standard packing was used. In this segment, I'd like to discuss the installation of a mechanical seal. Many pumps can be fitted with either standard packing or a mechanical seal. The type of sealing arrangement depends upon what the pump is going to be used for. So let's join the workman now as he installs a mechanical seal. As always, before doing any work, the workman checks the manufacturer's instructions. The first thing he's going to do is mark the shaft. So he holds a scribe against the shaft at the top of the packing gland. As the shaft is rotated, the scribe makes a mark. This mark will be used as a reference point for the seal installation. Next, he removes the cap screws. After the cap screws are loosened and removed, the end plate will be ready for removal. He takes care when removing the end plate. If it's dropped or banged on the shaft, it could damage the shaft. Next, the workman assembles the stationary unit. He installs the bottom gasket. Then the stationary seal. He's careful not to touch the seal surface. Must be kept extremely clean to seal properly. Finally, the second gasket is installed. Again, he's careful not to touch the seal surface. Next, he places a drop of oil on the seal surface. The oil is spread around with a clean tissue. He then slides the follower flange and stationary unit onto the shaft, with the stationary seal facing out. Now the rotating element is ready to be installed on the shaft. The workman aligns the end of the rotating element with the scribe mark. Then he tightens the set screws, which hold the seal on.